When we start interpreting derivative values, one of the first things we look at is the sign of the derivative. When we see notation like this, f prime of x is less than 0, just remember that this is a slope. And if a slope is defined, and is greater than 0, then that means that it is positive. And if you think of positive slopes, straight out of the grade 9 canon of how to draw graphs, that means the function is moving upwards. Your rise over run is positive. Well, that means your function is increasing. So if you see a positive derivative, that means your slopes are positive and the function is increasing. Likewise, when you see negative slopes, or again, derivative in the new notation, that's negative, then you're going to see a function that is decreasing. We can't give many more details. All we know is that if you do rise over run, you're going to have a negative value. So your rise is actually a drop instead of a rise. One feature that's going to come into play a little later on in important tasks like optimization is recognizing the transition point, which is when the derivative equals 0. Again, this is slope equals 0. And remember that a slope of 0 is a horizontal line. Doesn't have any rise for the same run. And we see that at very interesting points like possible maxes and mins for graphs. We take the point where the slope is 0, you'll see some interesting properties. Again, these will be the two more common scenarios where points tend to be either positive slope or negative slope, but there's the occasional one that is at the boundary between increasing and decreasing at slope or derivative 0. Let's take a look at a graph example. If we have this function here, we can ask on what intervals is f prime of x greater than 0? If you're familiar with derivatives, this is easy. If you're not, just remember that translation. F prime is a slope. The instantaneous slope, slope of a tangent, all that extra stuff. But at the end of the day, it's a slope, and greater than 0 means positive. So we just look for all the points where the slope is positive. It's definitely not positive on this interval here, but from D all the way up to F, we're going to have positive slopes. So between A and B, and from D to F, D to F. On the other intervals, the function is decreasing or the slopes are negative. Looking at the same graph, we can ask some other deeper questions like, where does f prime take on its largest negative value, or most extreme negative value? You can think about that for a second, and then we'll take a look. Remembering again, if the slope is large, that means steeper. If we have negative slopes, that means decreasing. So what we're looking for is the combination of these two, the steepest decreasing point. Well, here we're increasing, here we're going down, but think of this as a roller coaster. Where is the slope the steepest? Right here at C. After that, and actually a whole bunch of points, it looks pretty similar all the way along here, but C looks like the center point of that region, or that interval. And as we come down and down and down, eventually it starts getting less steep. So imagine drawing tangent lines. The point where things are most steep and negative is going to be at the point C. To be thorough, we should look a little further along. If we compare the slopes, even at G here though, they are not as steep as the slopes on that large drop-off section around C.